Uh, Today we're going to talk about a new chapter, Discrete Probability Distribution, which is a continuation of the previous chapters about a survey of probability. This is basically about the topic of inferential statistics, which talks actually about the probability that something probably will take place in the future. Here, before we go further in this chapter, let's talk about or summarize basically certain important concepts. Namely, we have to differentiate between variables. We have discrete variables and we have continuous variables. Remember that when variables are associated with probabilities are called random variables. So random variable is a variable whose values are determined by chance or are associated with the probabilities. So here, of course, by observing the values, the variable can assume we basically classify two types of variables, namely discrete variables and continuous variables. Remember, we usually, a variable usually is defined as a characteristic or attribute. Okay. For instance, here, if we talk about discrete variables, we know that discrete variables have a finite number of possible values or an infinite number of values that can be counted. So discrete variables, of course, are variables that are used to represent outcomes that can be counted. For instance, if we said, for instance, how many rooms your home, have your home, how many rooms does your home have? You could say, well, my home consists or has 3 rooms or 4 rooms. It can be counted. You can say, for instance, my home consists of 2.5 rooms or 3.5 rooms. So these values or outcomes are counted, either 1 or 2 or 3 or 4 or 5, whatever. Okay? Now, the other type of variables are called continuous variables, which assume all values in the interval between any two given values. Of course, continuous variables are obtained from data that are measured rather than counted. For instance, if we talk about weight or height or temperature, we talk about continuous variables. For instance, if the weight of somebody is 78 kilogram, okay? If this scale is recorded to the scale of thousands, we could say, for instance, his weight is 73 kilogram. And if it is recorded to the, the scale is recorded to the scale of thousands, then I could say it's 73.678. This is, of course, a continuous, variable. If the temperature, if the temperature during the day is between, for instance, temperature during the day is between, for instance, 25 Celsius to 36 Celsius, okay? Then we could say here, it could trace all values between 25 to 36. It could be, for instance, 25.3 Celsius, or it could be 29.67 Celsius. Okay, so if the height of somebody is 1.6 meter, or it could be 1.65 meters. or could be 1.5 or 1.659 meters. So these are examples of continuous variables. So here, before talking about discrete probability distribution, it's important that we have some knowledge or information about the difference between discrete variables and continuous variables. Today, we're gonna focus upon discrete random variables. We said random variables are variables that are associated with probabilities. Okay, now we're talking about probability distribution. First, let me just emphasize the fact that we are in this chapter focusing upon probability distribution. Okay, discrete distribution. Okay, a discrete distribution that is the result of counting. Okay, now probability distribution is a listing of all the possible outcomes of an experiment and the probability assigned to each outcome. So here we have the possible outcomes and their probabilities. Now let's differentiate between a random variable and probability distribution. We said that the probability distribution is the listing of all the possible outcomes with their probabilities. However, a random variable, of course, only talks about the outcome of an experiment. It reports the outcome, a certain outcome of an experiment. This is a random variable. However, a probability distribution reports all the possible outcomes and their probabilities. Okay? A discrete random variable, of course, it is a random variable that reports a certain number of separated values. Okay? An example of discrete random variable is, for instance, the number of students earning an A in the class. Could be 0, could be 1, could be 2, could be 3, could be 4, and so on. This is a discrete, numbers. Now, of course, a probability distribution has certain characteristics or requirements. Let's see these requirements. The first requirement of a probability distribution is that probability of a certain outcome is between 0 and 1. That is, the probability of x, which is the x, of course, or the letter of the alphabet, as I said before, is used to represent a variable, okay, whether x or y or z. So this is probability of x, the probability of the variable x, okay, is between 0 and 1, inclusive. It could be 0 or it could be 1, okay? It could be 0 or it could be 1. For instance, if we toss a coin, we get two outcomes. We get a tail or a head. The probability of a tail, because we have two outcomes, okay, equally likely. Therefore, the probability of a head is the same as the probability of a tail. The probability of head is 1/2, and the probability of a head is 1/2 also. Therefore, the probability is between 0 and 1 inclusive. The second requirement is that the outcomes are mutually exclusive, which means that there is no any intersection between them. So if you get a head, you cannot get at the same time a tail when you toss a coin. So they are mutually exclusive. Okay. The third requirement is that the sum of the probabilities of the various events is equal to 1. That is, the sum, sigma, of p of x is equal to 1. Because the sample space consists of all the possible outcomes of a certain experiment. Therefore, the probability, the sum of the outcomes in a sample space is equal to 1. Now, let's give an example of probability distribution. Let's give an example of probability distribution. This is the example, of course, generating a probability distribution. This is the focus of this example, how to generate a probability distribution. The question is that what is the probability distribution for the number of tails showing face up on two tosses of a coin? So we get two coins, we toss the first one, Okay, we get head or tail, and we toss the second coin, we get also head or tail. Now, our focus in this question is to generate a probability distribution for the tosses of two coins. Now, look over here. The tosses of a coin is an experiment. When we toss a coin or we roll a die, this is an experiment. Okay? Now, we can use a tree diagram to find the possible outcome. This is the tree diagram that we discussed in a previous lesson. Of course, we got here the the starting point. Okay, when we toss the first coin, we got head or tail, either head or tail, and when we toss the second coin, we got head or tail. If the first outcome is head, okay, and we toss the second coin, we get either head or tail. If the first outcome of tossing the first coin is tail, and then we toss the second coin, we get either head or tail. So the number of possible results, of course, the outcomes that we get, the total number of results or outcomes that head, tail, tail, head, tail, tail. Okay, so the possible results: 1, head. To the number of tails is 0. We are concerned in this equation about the number of tails. Okay, the number of tails showing face up on two tosses of a coin. So the first event or the first outcome is head. So here we don't have any tails, so we have 0 tails. The second one, head, tail. So we get only 1 tail in this outcome here. Then the third outcome results is tail, head. That is tail, head. We got only 1, tail in this outcome. Okay, and then tail, we get 2 tails. Okay, 2 tails. So this is of course, these are the possible outcomes when we toss 2 coins. Now, therefore, the probability distribution for the events of 0, 1, and 2 tails. We have 0 or 1 or 2 tails. Okay? What is the probability distribution for these events? Either 0 or 1 or 2. 0 tails, or 1 tails, or 2 tails. How many, we have, how many heads we have here? How many tails we have? We have 0. And 0 out of 4. So the probability is that 1 over 4, which is 0.25. So that's what you get. Number of tails, either 0 or 1 or 2. Okay? So number of tails, either 0 or 1 or 2. Now, the probability of outcome, 0, we get what? 1 out of 4. 1 out of 4 outcomes, we get 0. So we get the probability is 1/4 or 0.25. Remember, we represent the probability either as decimal or as a fraction. Okay? Now, a number of tails is 1. So we get here 2. 2 results, we get 1. Okay? So we get 2 out of 4. Therefore, the probability of getting 1 tail is 2 over 4 or 0.50. Now, if we get, here we get 2 tails. Here, remember our concern is the, number of tails. So we get 2 tails. Okay, the first one number of tails 0. And the second one number of tails is 1. The third one number of tails is 1. In the fourth outcome, number of tails is 2. Okay, so we have 2 here. Okay, now as you can see here, how many outcomes we have 2 tails? Only 1. 1 out of 4. So the probability of this is equal 1/4, which is equal 0.25. The total, of course, should equal to 1. As we said over here, the third requirement, that the sum of the probabilities of the various events is equal to 1. Okay, that is sigma px is equal to 1, which is equal to 1, as you can see. Of course, we can represent the probability distribution, we can represent it graphically. We can represent it graphically, as you can see over here. we got XY plane. Along the Y-axis, we have the probability. And along the x-axis, we have the number of days. The number of days, we have 0, 1, or 2. 0, 1, or 2. Okay? Now, when we get 0, the probability of getting 0 is what? Is 0.25. The probability of getting 1 is 0.50. This is, we draw a straight line, a vertical line that, come up to here, to 0.50. The probability of 2 is what? 0.25. That's 0.25. So we draw a vertical line up until it hits to 0.25, until it is, equal to the height of 0.25. So this is here the probability distribution shown graphically. Okay, now we move on to talk about the mean of probability distribution. Is represented by mu. Mu, this is the lowercase Greek letter mu, which is used to represent the mean or the expected value or the central location of the data, which is equal the summation sigma, which represents the summation x times dx. X, the value, of course, which is represented by a letter of an alphabet. X or Y or Z, so X times Px. Px is the probability, okay? So the summation of the multiplication of the value of X and the probability P of X will give us, the summation will give us the mean or the expected value of the data, which basically represent the central location of the data. Now, the variance of a probability distribution, remember the variance, of course, is used to represent the spread in the data, okay? The variance of probability distribution is used to represent the spread or the central location of the distribution. Also, it is, the sigma square, which is the lowercase Greek letter sigma, is used to represent the variance, sigma square, which is, of course, the summation of the, x minus mu square times px. The summation of this will give us the variance, okay? So when we subtract the mean from each value and square it, then we multiply this, square difference by the probability of the variable, we come up with the variance. The standard deviation, of course, is the positive square root of sigma squared, which is sigma is equal to the square root of sigma squared. Now, to understand these, new concepts, there's an example over here. Let's talk about this example and see how we, solve the problem. The example says, consider the following information for the number of emergency calls made by the ambulance service for the last 100 days. Okay? Now, the data is listed as you can see here. You have the number of calls, okay, which is, we represent this by X. You get 0 or 1 or 2 or 3 or 4 or 5. The frequency, when the number of calls 0, we get 15, okay? 15, 25, 20, 10, 5, 25. The total number of these, frequency values is 100, okay? Now, we have 3 questions over here that, concerns 3 questions that concern this data over here. First question, convert this information on the number of calls to a probability distribution. Remember, a probability distribution basically lists, the outcomes and their probabilities. Is this an example of discrete or continuous probability distribution? Of course. Calculate the mean number and the standard deviation of the number of calls made daily. Okay. First, convert this information on the number of cores to a probability distribution. This is the solution over here. As you can see, the cores, we represent this by x. We set the value of course, is represented by the letter of the alphabet, x or y or z. Now we represent it by x. Okay, so we have 0, 1, 2, 3, 4, 5. Now, the frequency, as you can see those, we, write them, we copy them again here. We get the frequency as you can see them. Now, the probability, of course, we need to find the probability. Now, if the frequency is 15, then the probability, of course, 15 over, 100, as you can see. So we come up with 0.15. This is the probability. The frequency, 25. So to find the probability 25 over 100, 0.25. 20, to find the probability when the frequency is 20 over the total, okay, number of, outcomes. We get here 20 over 100, we get 0.20, 10 over 100, 0.1, 5 over 100, 0.05, and 25 over 100, we get 0.25. So the total number of probabilities, as you see, is 1 is equal to 1, because this is the requirement we just talked about the sum of the the probabilities of the sample space is equal to 1. So we have 1 over here. Now, of course, we need to find now the mean. He said, of course, is this an example of discrete, or of course, this is an example of a discrete, because a discrete, of course, talks about discrete random variables, talks about the value of an outcome that is basically is separated, which is either 1 or 2 or 3. Okay, so this is, of course, it is a discrete random variable. It's not continuous. Of course, it's not continuous. These numbers are counted. Are the result of counting 0, 1, 2, 3, 4, 5. So it is a discrete random variables. Okay. Now we need to calculate the mean number, and so here I could say B. This is here C. Of course, B over here. Of course, over here is we get A and C. B, we have a discrete random variable, because as you can see, these are numbers, okay, and they are separated, okay. You get 1, 0, you get 1, 2. There is separation between them. There's a gap between them. So, and they are the result of counting. Therefore, we have a discrete random variables. We have a discrete random variable. So now we move to talk about or to calculate the mean and the variance and standard deviation. Of course, he said calculate the mean and the standard deviation. Of course, before you calculate the standard deviation, you calculate the mean. So here, of course, we list the the simple method of finding the standard deviation of the distribution. You go like this. You get the x, the variable x. You get the frequency. If he is giving you frequency, sometimes doesn't give you frequency. The question will right away it gives you the probability. So we calculate the probabilities. Now we need to calculate the mean. We multiply the x times the probability. 0 times 0.15, you get 0. 1 times 0.25, you get 0.25. 2 times 0.20, we get 0.40. and so on and so forth. So we come up with all these things. So mu is used to, stands for the mean or the expected value, of course, of the distribution. So this is a mu. We sum all of those numbers, values, we come up with mu equal 2.4. So this is the mean of the distribution, or the expected value of the distribution is mu equal 2.4. Now we move to calculate the variance. So what we do, the variance, as you can see, is the summation of x minus mu squared. So we have to subtract the mean from each value of x and square it. So this is x minus mu. We subtract, the mean from each value of x. 0 minus 2.4, 1 minus 2.4, 2 minus 2.4, 3 minus 2.4, 4 minus 2.4, 5 minus 2.4. So we get, x minus mu. So now, of course, we get the result of each one and square it. So 0 minus 2.4 minus 2.4, we square that, we come up with 5.6 or 5.76. Okay, 5.76. 1 minus 2.4 is minus 1.4, and then we square that, we come up with 1.96, and so on and so forth. So we square the difference of, x minus mu, square that one, okay, we square the difference of this, and we come up with these values. Okay, this is the square of the difference of mu and from x. So we come up with this is x minus mu squared. These are the values. Okay, now, of course, x minus mu squared times bx. So we multiply x minus mu squared times bx. So we get 5.76 times 0.15 times 0.15. 1.96 times 0.25, 0.20 px. 0.16 times 0.20. 0.36 times 0.1. 2.56, we get it here, times 0.05. 6.76, we get it here, times 0.25. And then what to do? We sum. We need to sum. This is sigma, capital sigma, is used to denote summation. Okay? Summing up all the values. We sum up all those values, we come up, and the summing up of all these values will give you the sigma square, the variance. So sigma square equals 3.24, and then now we can calculate the standard deviation, which is the positive square root of this, and we come up with 1.8. But this is, of course, the standard deviation of the of the distribution. Okay, we move now to another topic in this chapter, discrete probability distributions, which is we'll talk about binomial probability distribution. Remember that discrete probability distribution, of course, which is the result of counting something, such as, for instance, the number of students earning, for instance, a B in a class. 10 students, 20 students. So it's the result of counting something that's called discrete. Now here, binomial probability distribution is a widely occurring discrete probability distribution with the following characteristics. So when we say binomial distribution, it means because many probability, of course, have only two outcomes or can be reduced to two outcomes. Okay, these type of probability, are referred. These type of probability, problems is called probability distribution, binomial distributions. So when it has two outcomes, or the probabilities can be reduced to only two outcomes. Now, what are the characteristics of a binomial distribution? Of course, first of all, there must be a fixed number of trials. Okay, we have a fixed number of trials. I give example here. For instance, a microeconomic exam consists of 50 multiple choice questions. So the number of trials in that microeconomic exam is 50 questions. These 50 questions, the number of questions in the exam is 50. Therefore, it is fixed. We have only 50 questions. So the number of trials must be, of course, fixed. Of course, each, question consists of some choices, perhaps 4 choices or 5 choices. But however, the number of questions in the exam is fixed, which is 50. The second characteristics of a binomial distribution is that each trial has only 2 outcomes, or outcomes that can be reduced to 2 outcomes. These outcomes can be considered as either success or failure. Now, when we say success or failure, does not imply that the success is good and the other one is bad. It's just, a term that is used to indicate that one of the choices, one of the outcomes is success and the other one is a failure. Now, an example of this second characteristic is the following. First, when a baby is born, it will be either a male or female. Remember, you can't have the choice, either male or female. And the outcomes here are mutually exclusive, which means that you can't have a male and female at the same time, either a male or female. Therefore, the outcomes are mutually exclusive. Another example, a medical treatment can be classified as effective or ineffective. Here, as we said at the beginning, that when a probability that has 2 outcomes or can be reduced to 2 outcomes. Here we're talking about, we have reduced the outcomes of this medical treatment into 2. We call them one effective and the other one ineffective. So we have 2 outcomes. One is called effective and the other one is ineffective. Or one successful and the other one is not successful. So we say here that we have only 2 outcomes, okay? And the outcomes are mutually exclusive. The medical treatment is either effective or ineffective. You can't have, the outcome to be effective and ineffective at the same time. Therefore, the outcomes are mutually exclusive. The third characteristics of a binomial distribution is that the trials are independent, meaning the outcome of one trial does not affect the outcome of any other trial. We talked when we explained a probability in the other chapter or lesson, we have talked about the meaning of independence. Example of this, a young family has 3 boy children. A young family has 3 children who are boys, who are males. The probability of a fourth bird being a boy, that is a male, is still 50%. It's not, affected, by or whether the family has boy or girls. Therefore, the gender of the 4th child is independent of the other 3. Okay? Because, as we said, that is the meaning of independence. Okay? So whether the family, has a boy or a girl in the 4th child is independent. It's not affected by the other outcome, okay? Therefore, the outcomes are independent of each other. The fourth characteristics of a binomial probability distribution is that the probability of success and failure stay the same for each trial. So, for instance, in let's say we take the first example here. A microeconomic exam consists of 50 multiple choice questions. Let's say each multiple choice question consists of 4 choices. Therefore, the probability of guessing a correct answer of each question, of each trial is 1/4 or 25% or 0.25. Okay, so it's always fixed. Guessing correctly the second question, of course, or the second trial is still, is 1/4 or 0.25. Therefore, the probability, of success or failure, it remains the same. If the probability of success is 1/4, then the probability of failure is 3/4. Okay, now let us, of course, see the formula of computing, any probability using the binomial distribution. The formula of the binomial distribution is given here, which is P of x is equal combination and x times pi to power x into 1 minus pi n minus x. Let us, identify those, terms where C denotes a combination. Remember, combination, we said that before. Okay? N is the number of trials, the total number of trials. For instance, if we have a 30 true false exam or a 30 true false test, then the number of trials is 30. X is the random variable defined as the number of successes. Okay, X the one that we define because in a binomial distribution we have only 2 outcomes, a success or a failure. Okay, we have only 2 outcomes, that one is success and the other is failure. So X is the random variable that is defined as the number of successes. Y is the probability of success. We have already discussed the characteristics of a binomial probability distribution. We said that, Y, the probability of a success remains the same. It's constant. So it is the probability of success. The mean of a binomial distribution is given by, mu is equal and pi, where mu stands for the mean, which is the Greek lower, case letter, which is called mu, which is used to denote the mean, mu, which is n times pi. So when we multiply the total number of trials times the probability of success, we come up with the mean of the binomial distribution. The variance of a binomial distribution is, of course, denoted by sigma squared, which is sigma is the lower case, Greek letter, sigma squared is used to denote the variance, of course. So the variance of the binomial distribution is equal to n times pi into 1 minus pi. So let us here have an example that basically applies the formula and the other, the other characteristics of that formula, namely the mean and the variance. Okay? So in this example, we say that we have a binomial distribution that has n, the number of trials is 5, with pi equals 0.30. So the probability of success is 0.30. Using the binomial formula, which is here, determine the following. A, the mean and the standard deviation of the distribution. B, the probabilities of the following events. And 1, x equals 0. The probability, of course, is the random variable, the probability of the random variable x, which is equal 0. 2, the probability that x equal 1, and 3, the probability that x equal 2. So, in the first part of the example, A, we need to calculate the mean and the variance. The mean, as a case, this is the formula. The mean of the binomial distribution is mu equal n bar. So we multiply n, we have n equal 5, the bar is equal 0.30, so we multiply both, we come up with 1.5, which is the mean of the binomial distribution. Now, the second part is to calculate the variance of the probability distribution, and the variance using this formula, sigma square equal n pi into times 1 minus pi. So n pi times 1 minus pi, okay, when we plug the numbers and multiply them, we come up with 1.05. So 1.05 is the variance of the binomial distribution. Now, we need to go to solve part B of the example. Part B, we are required to calculate the probability of x equals 0. The probability of x equals 0. So we need to find the number of successes, x, okay? The number of successes is 0. So we plug 0 in this formula, x equals 0 or 0. Probability of x equals 0 is equal, see here, see the combination. So we have combination and x. N is 5 and x is 0. So we plug them in the formula here, okay, and we calculate this. Okay, remember that C combination 5, 0 is equal 5 factorial into 0 factorial into 5 minus 0 factorial, which is equal 5 factorial over 0 factorial is 1 times 5 minus 0, which is 5 factorial. So cancel out, we come up with 1. And so on and so forth with other, x's. Probability of x equal 1, we plug, x equal 1 here. It's x we put 1. And, of course, the number of tries, of course, the total number of tries is fixed, which is 5. We plug them in the formula, and we come up, of course, with 0.36. So the probability of x equal 1, okay, is equal 0.36. The third part of, subpart of part B is that probability of x equal 2, of course, is equal, we plug 2 in the formula over here, instead of x we put 2, okay, same number of trials and 5, and then we come up with this, when we plug them, we come up with 0.387. This is the probability of getting, 2 successes.